so what you're working on here is graphing functions. And then the last lesson you had vertex form, which is y equals a times x minus h squared plus k. And our vertex was h comma k. So it was pretty easy to see where the vertex was. A, remember, made it either, if a was positive, it made it open up. If a was negative, it made it open down. And how wide it was. If a was a fraction, it was kind of really fat. And if a was a big number, greater than 1, it was making it skinnier. But we could see the vertex right away. And we see that none of these are in standard form, right? None of these questions that we see here in standard form, because we don't see this x minus h squared part at all. We see the squared here. So that's letting us know that it's squared. So how do we graph when we have standard form? Well, let's just remember standard form is ax squared plus bx plus c. So the value of a is always with the squared, the value of b is always with x, and the value of c has no variable. So, and all of these are in that order. Number 19, we don't see a c, but we can just have it be 0. All the rest of them are written in that way. So you could just do a table of values, by the way, and graph these. But it takes a long time because you don't necessarily know where the vertex is. So a very, very smart person said the x-coordinate. So the x-coordinate of the vertex equals negative b divided by 2a. All right, so when I look at, let's take number 17 here. So number 17 says y equals x squared, and because there's no number in front of it, the only thing that can go in front of something and not change it is a 1. So we put this 1 here, and then we have plus, all right, so let's pick a color for b. We'll have b be here, 6x, and then plus, we have c. Let's give c a different color. C can be black here. That's what I have up here. So here's our a, here's our b, and here's our c. So now we can find this x-coordinate of the vertex. This is going to be a negative value of b. Since this is positive, I'm going to keep that negative. And then 2 times a. So 2 times 1 is just, so we have 2 times that a of 1. So we have negative 6 divided by 2 equals negative 3. So what is that telling us? That's telling us, if we do a little grid here, that where x is negative 3, that's where our axis of symmetry is, and our vertex is someplace here, right? It's someplace, but we don't know where yet. So how do we find out the y value? Sorry, my screen just messed up. How do we find the y value? Well, to find the y coordinate, maybe we can get green or something here. The y coordinate, we need to take that value of x and we need to put it in our function. So 1 times negative 3 squared. I'm just taking this function right here. I'm plugging it in. So I'm putting negative 3 into those spots and I'm finding out what y is. Plus, all right, so now I'm going to have 6 times negative 3 plus 9. So that negative 3 squared is 3. Sorry, negative 3 squared is 9. 9 times 1 is 9. Plus 6 times negative 3, so that's plus a negative 18 plus 9. Oh, that's kind of nice. 9 plus 9 is 18. Negative makes it be 0. So it tells me that my vertex, right, my vertex is at negative 3 comma 0. And I put that on there. Right, and now all of a sudden, it's pretty simple to use this table of values because we have it doing something, and this is the axis of symmetry, right? You said it's identical on either sides of it. So I'm going to put in when x is 0 because 0 is a really easy number, right? 0 squared plus 6 times 0 plus 9. 0, 0, that's 9. So when x is 0, y is 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. A little bit tricky, but I went 1, 2, 3 this way, so I go 1, 2, 3 this way. And since that's symmetrical, I'm done, right? So I really didn't even need a table of values. This is called the Y-intercept, right? The Y-intercept really helps us do that. So let's try one more, and then you got to work on them. So this was 17. Let's pick something that's hard. Let's do number 22 because that's got that fraction in it. So y equals negative 3/4 x squared plus 6x plus 6. All right, what did we do first? We had to find the x-coordinate. So the x-coordinate equaled negative b, so negative 6 divided by 2 times a. All right, so let's see, we got some space here. Negative 6, 2 is going to go in here once. It's going to go in here 2 times, so that's negative 6 divided by negative 3/2. All right, with fractions, I could get out my calculator, and I would be completely okay with you doing that, but it's not easy for me to do. So when I have division of fractions, I'm really multiplying by the reciprocal, right? So I flip that over, and that's going to be positive 12/3. 12 divided by 3 is just 4. So now I know my x-coordinate is 4. Step 2, I got to plug that back into y. So y equals negative 3/4 4 squared plus 6 times 4 plus 6. All right, negative 3/4, 4 squared is 16. Plus 6 times 4 is 24, plus 6. All right, 4 goes into 4 once, goes into here 4 times. That's negative 12 plus 24 plus 6. All right, this is going to be 12 because 24 minus 12 is 12 plus 6 equals 18. So, whoops, I don't know what happened to my line there. I'm at 1, 2, 3, 4, and 1, 2, 3, 4, 4, 5, 6. It doesn't like doing this. 1, 2, 3. I'm someplace way up here, right? Where this is going to be 4, comma 18 is my vertex, and my parabola is facing down, so I know it's going to go down, but I can still use that y-intercept. That's my next best point. My y-intercept is when x equals 0, so 0 times anything is 0. 0 plus 6, so I know it's going to be 1, 2, 3, kind of right here, and since that was 1, 2, 3, 4 this way, 1, 2, 3, 4 this way, means I'm going to have a graph that looks about like that. All right, so find the x-coordinate with this formula, right? This formula helps you find the x-coordinate. Plug that into x, and you find the y-coordinate. Then use the y-intercept to find one side, and use your imagery, your axis of symmetry. Use the matching on the other side. All right, I hope that helps. Let me know what other questions.